Hello, Math 241 students. Welcome to the final class. We're going to do a final project in which each of you is going to describe a lesson that actually you're going to make a lesson and then share it as a video for each of us. And you will each review 3 of your classmates' projects. So I've tried hard to see if I can outline each of the steps. So the first thing I want you to do is to just think about your ideal classroom. Are you going to teach in a middle school or a high school? What topic are you going to teach? What about your students? Are they going to be English language learners, or are they going to be maybe an AP calculus class? Are they going to be students who are working towards understanding? Think about what you would really love to teach the most. Then pick a topic that you would really like to teach that would fit into this classroom. So at this point you might be thinking, I have no idea. So I have compiled here some examples that you might want to look at here. So if you click on the control click. In middle school, ratios and proportional reasoning are critical. Geometry, solving real-life problems involving angle measures, surface area, and volume. These are statements taken directly from the Common Core standards. Maybe in algebra, think about equations and inequalities, or creating a description of, I don't know, how you complete the square, for example. And obviously things like writing equations of lines. One of the things that students find most difficult is the idea of piecewise functions, even in 400 level engineering classes. At the high school level, think about certain functions: exponential, quadratic, logarithmic, trig functions. Maybe think about domain and range, which I know you have thought about a lot after doing your art project. Again, geometry, we did a whole module on geometry. Maybe you want to think about how you prove congruence, or look at revolutions or transformations. In the modeling section, using functions to model how things are changing. Conics, obviously Desmos has a lot of ways that you can explore conics, polar coordinates, parametric graphing. These are just some examples of what you're going to do. So, by the way, I did tell you it's a Desmos-based lesson, obviously. Now, if you want to see what in the world these videos might look like, you can look at some videos from prior years. Now, the videos that I have here are when students were using a different program. They were using GeoGebra. But if you click here, you can see links to all of their projects. What I had them do is ask a question, because they were not as much doing a lesson as looking at how they could describe a particular mathematical phenomenon. But you can see most of them uploaded to YouTube, and that's the easiest way to do it. Is you upload to YouTube, and then you're going to send me the description, the URL, sorry. All right, so then once you've got a topic, you're going to decide if you want to make a lesson on your own, or if you want to modify existing one. One of the most valuable parts of Desmos is that there are millions and millions of examples already out there. So one way to do this is to see what's already out there. And one way to do it is to go to teacher.desmos.com. But those those lessons are ones that were created by the Desmos team, and they're already excellent, but they may not be completely ready for making changes. You can definitely make some changes whenever you want to do that. Another way to do that is to if you just go to Google here, I'm going to move. So if you, let me see here. I'm going to move this up so you can see, but if I just go to Google here, google.com, and then I might type in something like Desmos, let's just say I want to do proportional reasoning. Proportional reasoning. Then what you see is a list of projects that teachers have done. Now this one says Activity Builder by Desmos. This one, looks like it might have been just a teacher did it. Not just, I don't mean it like that. Here's one that's really cute called Marcellus the Giant. There's a whole bunch of ones that you can see that other teachers have created. So let's see now. Going back to our list here, so that gives you some examples of what you can see. going to move this back down here so that you can see what I'm seeing. There we go. So, as I said, type the word Desmos into the search box along with the topic that you want to look up. I want you to, if you do use someone else's, I want you to have at least 30% of the slides be your own. So if you have, 10 slides, then add 3 of them. If you have 5 slides, add 2. Then you're going to think about what kind of criteria you're going to use to figure out what to add. That comes in the activity that we did, remember, in week 1 and 2 when we looked at the design characteristics. So you looked at some of the already existing work, and some of you said, well, gee, this one's too long, or this one was good, but now is your chance to fill in that but and make the lesson perfect. So once you figure out what you're going to do, either modify an existing activity or make your own, then you want to go ahead and make the slides. And once you've perfected your lesson, you're going to create a video that you narrate. And what I want you to do is to follow this script. So you're going to click on follow this script here, and you're going to just say what's your name, what's the classroom, and you can assume a few things. You can assume that they have technology. They understand how to use student.desmos.com. Maybe they're using Chromebooks or tablets. And then once you make your lesson, you want to tell us, I spelled that wrong. Did you make one from scratch or did you modify it? And then as you want to walk us through the entire lesson. However, the video can only be 5 minutes. This video is already 6 minutes. It's amazing how fast the time goes when you're talking instead of listening. But I'm sure you're tired of listening to my voice. Same thing. No more than 5 minutes. So don't simply say, the most important thing here is what is the mathematics that you're trying to get at. And what I notice over the years is that students will say, I want to teach a lesson on slope of a line. But that's not enough. What I need you to do is just particularly say, what about the slope of the line do you want them to understand? For example, you might say, the goal is to have students understand slope as a ratio of rise to run. They'll think about slope as a fraction, not just one number. This will be done by examining cases where the rise is larger than the run or the rise is smaller than the run, however you want to do it. But be more precise, but also expand more than just one sentence about what the mathematics is. And then state what you're assuming in terms of their understanding. For example, they already understand what rise and run is. Sometimes people have lessons where they basically just start off with a whole bunch of definitions. Students aren't really interested in that, and neither are we. We know that you can make a lesson where you just present stuff. What we want to see is the really cool interactive games and activities or questions that you ask the students. So you're going to walk us through each of the slides of your presentation. And for each slide, I want you to say what makes it different from the others. Again, for example, some of you said when you were reviewing the slides, my goodness, there's so many slides that are repetitive. What I can say is that some students finish early and others finish late. So sometimes teachers add extra challenges at the end, maybe only assuming that 1 or 2 students are actually going to get there. But it's really great when you're teaching to have a variety of different levels of lessons or of challenges so that you can differentiate your instruction. All right. So then finally, I want you to describe at least 2 design features of your lesson. We've already talked about design features. You can go back and find that list that you used, and that will be important when you're presenting your lessons. So, all right. After you have followed that script and made your video, I'm going to send you also some descriptions on how you can make the videos. You can use Camtasia, download a free copy of that. You can also use Zoom, which is we get as students and faculty at SDSU. Or a third way is to simply set up your camera or have a friend hold your camera while you go through your presentation. Any of those 3 ways or any other way that you can get a video that you can upload to YouTube is fine with me. All right, so then you're going to send the video link to me. I will then send you an email with the links to 3 projects to review along with a link to a survey. So what the survey contains these review questions here. Whoops, wrong one here. Here we go. It's going to say, how clear were the instructions? Describe, critique the clarity of the instructions. Do the students know how to help? The level of cognitive demand. How difficult is the work the students are asked to do? Now that also, is there a variety of questions? You know, are students just plotting, or are they just doing multiple choice? Are they just explaining? You want to have a variety of different questions. And then language and precision. Is there opportunity for the students to justify their thinking? Is the language and precision of the narrator clear? So those are some things to think about when you are doing your peer review. And the peer review is to help you see different ideas that other people have come up with, as well as to provide thoughtful critiques of the lessons for your peers. So after this is done, I will send you the feedback. And also the final question on the feedback peer survey is, name one thing that the creator could do to improve this lesson. So then you'll have at least 3 descriptions of ideas to improve it. So the final step is this rubric here. Your description of your mathematics, how precise and thoughtful it is, that's 5 points. A thorough description of the organization of the lesson, the variety of the lessons in the slides in the lesson, thoughtful feedback that you provide others in the peer survey, the degree of creativity that you put into it. In other words, if you copied someone else's, that's great, but you need to have some creativity that you added. Also, you're going to get points for just being able to create and upload a video, a description of the design principles that you used, and the fact that you completed the project on time. If we don't have all the projects done by Tuesday night at midnight, I won't be able to create the survey. And so we want to be able to create the survey, and hopefully you guys will be able to fill out the survey, and we'll close it by next Friday. I'll write all of that down. So the total is 28 points. This is the largest points, obviously, of the semester. So I hope that this video has been helpful. I will obviously upload this huge document that has all these definite resources. It's also got a list of questions from textbooks. It's also got some other suggestions for projects you might want to do. This cracks me up. This is from a farmer's insurance commercial. They've got some math on there. Here's some more ideas. This is a really fun one. If you're at the high school level, you want to look at polar graphing. What happens when r equals a times the sine of b theta? What's happening with the number of petals in the circle? A bunch of other suggestions, log rules, or the quadratic formula. So that is all that I have here. And again, I will post all of this, and hopefully you can go through it slower. If you have any questions, feel free to email me. I really look forward to seeing your videos.